I'm here to talk about section 5.5, the trapezoid rule. This technique is used for approximating the area under a curve using trapezoids. You're used to seeing trapezoids on the right where the parallel sides are going horizontal. I'm going to take that trapezoid, turn it vertically, and create the three trapezoids that you see under the yellow curve. Area of a trapezoid is 1/2 base 1 plus base 2 times the height. What's unique about this formula and this technique is the y1 value, for example, is the base 1 of the trapezoid in the middle, but at the same time, it's base 2 of the trapezoid on the left. So in my formula, when I add up the area of all of these trapezoids, the y1 value is going to get used twice. The same thing is going to happen for the y2 value. Y sub 0 and y sub n are only going to get used once. So here's the setup. T stands for the area of all the trapezoids. The first trapezoid is 1/2 y0, base 1 of the trapezoid on the left, plus y1, base 2 of the trapezoid to the far left, times the height. And then I'm going to add however many trapezoids I have. So this will all the way be out to 1/2 y to the n minus 1, in this case y2, plus y to the n, the base 2 of the trapezoid on the far right, times the height. I can simplify this expression by saying the following here in blue. You notice there's going to be an h on every trapezoid. H is the horizontal distance between all the trapezoids, so I can factor that out. When I factor out the h and I multiply it by 1/2, I would have h over 2. The y0 sub 0 value is only going to get used once. The far right yn value is only going to get used once. All of the values in the middle, the y1 and y2 and so forth, will get used twice because they overlap. So if it's twice y1, twice y2, and twice the next to last yn. That is your formula to use for approximating intervals. You would do this with n subintervals of length h equals b minus a divided by n, where b and a are your upper and lower limits of integration. Here's an example problem. I want to approximate the integral from 1 to 2 of x squared with respect to x. I'm going to estimate this with trapezoids when n equals 4. N is the number of trapezoids. First thing I have to do is figure out the h value. As I just stated, the h value comes from the formula b minus a over top of n. In this case, b is going to be 2, minus a is 1. Those are your upper and lower limits of integration, divided by n, the number of trapezoids, in this case 4. You get an h value of 1/4. Now I want to create a t-table to find the x and y values to use of all of the parallel sides of the trapezoid. Those would be the base 1s and the base 2s. My t-table is going to start at 1 and stop at 2 because those are my limits of integration. And I found the equal spacing from 1 to 2 with the h value of 1/4. So I'm going to add 1/4 to 1 until I get to 2. So 1 plus 1/4 is 1.25. Add another 1/4, 1.5. Add another 1/4, 1.75. And add another 1/4, and I land at 2. That's going to give me my 4 trapezoids. The first trapezoid is going to be from 1 to 1.25. The second trapezoid is from 1.25 to 1.5. The third trapezoid is from 1.5 to 1.75. And the last trapezoid, the fourth trapezoid, is from 1.75 to 2. I now need to find the y values. If the function is x squared, I'm going to plug in these x values to get the y values. So x squared for the first y value would be 1 squared, 1. 1.25 squared gives me my second y value, which is 1.5625. 1.5 squared is 2.25. 1.75 squared is 3.0625. And 2 squared is 4. So now I'm going to plug these into the formula from the last screen. So plugging in, h is a fourth. A fourth is 0.25 divided by 2. The y sub 0 value is the base 1 of the very first trapezoid, which is a value of 1, plus twice y1, because y1 will get used on two different trapezoids. It'll be base 1 of one trapezoid and base 2 of another trapezoid, plus twice y2, plus twice y3, and then plus y4, which is base 2 of the final trapezoid, a value of 4. From this point, it's just order of operations to calculate t, which is 2.34375. So an estimation of the area under the curve of x squared from 1 to 2 using 4 trapezoids is 2.4375. Now, of course, you could also do this with the actual technique. So if you integrate x squared, you would have 1/3 x cubed, and then you're going to evaluate that from 2 to 1. So you plug in the upper limit, 1/3 2 cubed, and you're going to subtract from that 1/3 1 cubed. And you'll get a final answer of 2.333. That's not too far off from the estimation that the trapezoid uses. So there's no need to really show you another one. It's pretty much the exact same thing every single time. The idea is to first find h, the distance in between the trapezoids, and then to make a t-table where your lower limit is the starting point, your upper limit is the stopping point, and you're going to count from the stopping point to the starting point by values of h. Plug in those values into your function after the integral to get the y values, and then just plug everything into the formula. And that would be the trapezoid rule.